So I'm Sam. I am a software engineer here at Diagrid. So I get to work on some of our internal products, as well as help contribute to the Dapr upstream. Here at Diagrid, we work to boost developer productivity by providing tools and APIs for building cloud-native applications. And I'm here with Kendall, and I'll go ahead and let her introduce herself.
Yeah, nice to meet all of you. As Sam mentioned, my name is Kendall. I am one of the product managers here at Diagrid, formerly worked at Microsoft on the Azure Container Ops platform, and just excited to be here today and dive deep into the Dapr Service Invocation API. So what this will look like today, we're basically going to start with a very quick and brief Dapr overview. I know most of you or many of you may already have some Dapr knowledge, so this will just be about 5 minutes, making sure everybody gets up to speed. Then we're going to do a service invocation overview, right? Just briefly talk a little bit about what that feature is and dive into some of its more advanced capabilities. And then we'll also be doing a demonstration. So we have a local demo and a Kubernetes demo as well. And we'll talk about some of the recent API enhancements to service invocation and some of those capabilities. So this is basically what to expect in today's session. So at this point, I will pass it over to Sam and she will take over for a bit.
Thanks. So yeah, there's a lot of good that we get with Dapr. And what is Dapr? Well, Dapr is the distributed application runtime, and it is a portable event-driven runtime that works to enable application developers. It was founded in 2019 at Microsoft, and our two co-founders are who helped to create Dapr and work towards bringing it to where it's at today, getting to a stable release in February of 2021 with that 1.0. And Dapr has also just been recently accepted into a CNCF incubating project. So there's a lot of really exciting things coming out with Dapr. And what Dapr does at a really, really high level is it works to alleviate the challenges of building cloud native applications by providing a set of consistent APIs and SDKs that abstract away a lot of the complexities of microservice development for your application developers. So I'll go ahead and do an overview at this point. Here on this slide, you can see that you can work with a lot of different languages when it comes to working with Dapr. You have Go, Node, Python, and many, many more. So Dapr works to codify the best practices for building microservice applications into open, independent APIs, which we call building blocks. And as you can see in that middle bubble, so there's about 10 of them. And these enable you to build these portable applications with the language and framework of your choosing, whether you want to pick one or use a few of the different building blocks. They're completely independent, so you can use however many you want. And with Dapr, one of their philosophies is supporting incremental changes, right? So you can incrementally migrate existing applications to a microservice-based architecture, thereby adopting some cloud native best practices thanks to Dapr. And at the bottom there, you can see that it is platform agnostic. So you can work with different cloud service providers or even at the edge. And so something that we are really proud of is that Dapr is supported by many architects and application developers and trusted by small companies and large companies such as IBM, Microsoft, Alibaba Cloud, and even running in the International Space Station. So it really is the epitome of edge. All right, so to touch a bit more on the building block APIs, you can see here that Dapr is running in a sidecar pattern where you have your application logic with your Dapr sidecar. And the communication here is via HTTP or gRPC. Now, I mentioned that there are about 10 different building blocks. So you can see an example of what that state API looks like. And the benefit here, right, with all of these different APIs is you can use localhost. And so thanks to using that Dapr sidecar pattern, I can have a consistent URL across the board in whatever different development environment that I'm in, from just running it locally to in a production environment. And you can see, again, across all these different URLs, we have localhost, v1.11 state. So you can see the different API associated with the different building blocks. So it's really nice and easy to work with and understand. From there, Dapr has swappable components that it supports. So if we hone in on this left box, just to kind of get a lay of the land on what's going on here, we have 3 different microservices, each running with their Dapr sidecar. You can see the far left one is working with Azure Key Vault. It has some sort of secret information. It's also sending messages onto the Azure service bus. That off to the right, you can see there are 2 microservices subscribed. And the bottom microservice on the right is saving state to Azure Cosmos DB. So this is kind of the same architecture in the Microsoft Azure box, as well as the AWS box and Google Cloud. So thanks to Dapr abstracting away a lot of the complexities and making things swappable, we can easily make changes and go from different cloud service providers or different services by simply updating a manifest infrastructure YAML file. So as an application developer, I don't have to worry about updating my application logic if I have a business need that means I need to switch cloud service providers, right? Because Dapr is abstracting that away from me. And so, if someone comes to me and says, hey, Sam, switch to AWS, well, okay, let me just update my YAML. It's nice and simple. And also, one last thing on this slide, Dapr has over 115 components available. So there's a lot of flexibility in different ways you can go here. And we're also consistently bringing more and more into play and to stable. And so now that we've covered a quick Dapr intro, I'll pass it to Kendall to go ahead and do a deep dive on service invocation.
Awesome. Thanks, Sam. Can y'all still hear me okay? My monitors are a little messed up, so I can't see the Zoom window. I didn't want to interrupt the share. So hopefully everyone can hear me. If not, feel free to come off mute and let me know. So I'm super excited today to talk to y'all about the Dapr Service Invocation API. Obviously, as Sam mentioned, right, project started back in 2019. There's been a ton of growth in the project, a ton of innovation, specifically within existing building blocks, but also adding new building blocks as well. So it'll be fun to kind of do a refresher here and make sure you really understand the benefits end to end of what you get with the Dapr APIs, and more specifically, the Dapr Service Invocation API. So we know that Dapr comes to solve a very core problem, which is making it easier for developers to build these distributed applications. And one of the challenges that come with building distributed applications is you break a monolithic process into a bunch of processes that are now distributed across a network. So with that being said, we have to take into account new considerations, new challenges that developers are responsible for overcoming. So these are a lot of the standard challenges that we hear about when developers are looking to build these distributed microservice-based applications. So things like, how do I discover the various services within my solution, right? Now I went from having a single monolithic process to now 15 microservices that all do a subset of work. How do I make sure that they can all communicate, discover one another, interconnect, maybe even communicate? Standard API calls, right? So to me, this is really critical from the Dapr perspective, is that we get that consistent set of building block APIs. So as Sam mentioned, my developers aren't learning how to architect and redesign their code with a variety of SDKs and libraries, depending on the services that they're trying to use or how they're communicating with one another. Instead, they get the standard direct API for invoking, services across this network. In addition, one thing that I remember I learned basically back in the beginning of my career in technology was, so I was in a session and they were talking about how somebody said Azure never fails. So I worked at Microsoft and one of the new hires said, oh, Azure never fails, was doing a sales pitch. And one of the instructors was like, no, Azure will fail and it has built-in resiliency, right? Failure is inevitable. To pretend it's not is really setting ourselves up for failure, ironically. So we have to account for that, right? We have to make sure that we're building our applications in a way that we account for inevitable failure, inevitable network, transient errors, those kind of things. From an observability perspective, obviously it goes without saying that in order to understand how our services are interacting and also just generally the health of our services, We need observability. We need insight into the various services, how they're interacting with one another, and generally the type of calls that they're making. And so how do we instrument our application code with this type of, tracing or observability so that we have that? And then I would kind of clump security and middleware together in the sense that middleware can really be a security enabler, but ultimately, how do we encrypt traffic, right? How do we make sure that only services that should be allowed to call my application can, and services that should not cannot, right? Especially in these security hardened environments, we definitely don't want to have, giving every application as much privilege as possible, right? We want to give them the least amount of privilege. So how do we make sure that we do that in a consistent way? And then also, how can we perform, translations for these calls that are occurring between services in order to intercept them and maybe transform them in some way? So now that we've kind of listed all these challenges, which ultimately, if you build microservices, hopefully sounds really familiar, let's take a look at how Dapr actually solved a lot of these challenges, right? So we take those same categorizations and we now focus on the Dapr Service Invocation API and the benefits it provides. So first and foremost, Dapr provides service discovery using pluggable name resolution components. So that means if I'm running on my local machine, it can use something like mDNS. If I'm running on Kubernetes, it can use kubedns. But ultimately, it is essentially discovering where these services are running and brokering that connectivity. In addition, we know that it provides us that standard set of HTTP and gRPC APIs and in a performant way, which we'll talk a little bit about some of those performance benchmarks in a preceding slide. One of my favorite features in Dapr, which Sam will highlight at the end of this, is resiliency and the fact that resiliency is now stable. Sorry, Sam, stole your thunder there. But essentially just super excited to see resiliency not only become stable within the Dapr project, but just be provided at all. So this means that developers no longer have to use, I know in .NET, Poly was very popular as a library to basically implement, retries and circuit breaking patterns. You can now do that using Dapr, and some of that's out of the box for you as well. We get the built-in tracing and observability that Dapr provides, which once again, we'll dive into all of these as we go. And then we also get MTLS. So a lot of developers building distributed applications typically use some type of service mesh in order to get that encryption, but Dapr enables you to get that encryption without having to take on some of those other features of the service mesh, or maybe some of that overhead that you're not necessarily leveraging. And then last but not least, we also provide the ability in Dapr to implement middleware. So that can be inbound calls to the Dapr sidecar or outbound calls from the sidecar to your application. All right, I see we have a couple of questions. Do we want, Mark, should I pause here? Do we want to cover any of those before we keep going into the deep dive?
I'll be answering them mostly immediately, so I think you can continue.
Perfect.
But
okay.
Some other ones which I probably can't answer, then I'll leave them up to you for later.
Perfect. Okay, sounds good. I know that Mark can handle anything I can handle, so I guess we won't take any questions today. We'll let him handle it. So let's just talk about basically the Dapr Service Invocation API in action. So we know that Dapr sidecar is running, whether it's a process or in a container on Kubernetes. And we have two applications in this case, because obviously in order to invoke a service, we need to have one origin. So let's say our origin is application A, our invoked app is app B. Both of these will get a unique identity assigned to them through Dapr called an app ID. So Dapr app ID is a critical, unique identifier that essentially represents your application workload. So in this case, when we use that Dapr v1 invoke API, and once again, this is the raw HTTP API, but this could be wrapped in an SDK. So it might not look exactly like this, right? We might provide that, that SDK wrapper. But we'll see here, so the app A wants to talk to app B. So basically it's going to say v1 invoke. It's going to pass in the name of the app ID that it wants to invoke, and then the name of the method on that application which it wants to invoke, right? So we've got app B and the method C within application B. So before that traffic ever goes to app B, it's first going to hit the local Dapr sidecar running for app A. And that local Dapr sidecar will use the name resolution component depending on the platform that you're running on in order to essentially target and find application B, right? So once it's resolved that location, the communication will happen from sidecar to sidecar. Obviously, this is very similar to that kind of like mesh capability that you've probably seen before, where you have the sidecars that are communicating with each other and intercepting these calls. So we see the communication will go from sidecar of app A to sidecar of app B. This will happen over gRPC, just for performance reasons, for security reasons. So all communication between these sidecars is gRPC enabled, and also MTLS, right? You get MTLS, as I mentioned. And then, obviously then that Dapr sidecar for app B will pass on the invocation. And you can see here, we're basically just invoking app B at the method C. So the Dapr sidecar is essentially translating that request through that pipeline to app B. And then because this is service invocation and it's synchronous, we'll obviously see the response path follow a similar channel. So from a load balancing perspective, Dapr provides round robin load balancing of service invocation requests. So that's just something to also highlight. So that's what we got in a nutshell, right? Sounds great. Awesome. We love Dapr. Provide this MTLS, name resolution, but that's not it, right? Yeah, Sam, we're like, it's a party. It provides a lot more than that. So let's dive into one of my favorite features, which I did add animations to this. Unfortunately, they didn't come through, so you're going to get it all at one time. We love when we get all of it at one time. But we just saw the network path, right? We saw the call going from app A to app B and then returning, right? That's the normal path. But let's say that app A invokes app B and for whatever reason is not able to reach application B, right? We talked about this being inevitable, right? App B could have gone down. It could be transient failure within the network. So when that application call is unsuccessful, Dapr does provide us some built-in retries between those sidecars. So let's say that app A is able to reach isn't able to reach application B's sidecar. We'll get back some default retry policies, but we can also set our own custom resiliency policies. So in this case, we can actually provide a resiliency.yaml manifest, which is very much a Kubernetes object. It's the same way that we have Dapr components, we have Dapr resiliency, which is just another resource type within Kubernetes. So we can pass in a resiliency file. And what does this resiliency file have in it? And how does it actually tell the Dapr sidecar for app A how to retry these calls? So the first one is you're going to define a set of policies. So essentially, I can set timeouts, I can set retries and backoffs, and I can set reset circuit breaking, I can define a circuit breaker pattern. So this is essentially just saying, if my call takes X amount of time, I just want you to go ahead and return an error, right? Maybe that timeout is 10 seconds, 5 seconds, 20 milliseconds, whatever that might look like. And then I might also want to have particular retry logic, right? Either exponential or constant. I want to retry this call for a certain period of time. And then ultimately, let's say I have a retry forever policy, which we'll see in just a second. Eventually, I'm going to want to protect my application from essentially getting an influx of requests that we know it can't handle. So that's where the circuit breaker comes in. The circuit breaker can open for a given interval. It can let certain messages through and then essentially become half open. And then ultimately, it'll close, right? It'll close and allow that traffic to continue flowing through once the application has become reachable. So the important thing to call out when we look at the resiliency scope is there's two really important bits of information. So one is we assign policies to targets. So in this case, our target is application B. It's the target of our invocation call. And then we scope access to the resiliency policy, which basically says, I want this application to use this type of retry when calling the target. So in this case, we're going to scope access to our resiliency policy to app A, and we're going to target app B, which is essentially just letting us know, I want you to use this type of retry, this type of circuit breaker policy when calling app B. So we're going to see this in action in about one slide. So get excited. So in addition to resiliency, right, we talked about observability being another important aspect of being able to do service invocation well in a distributed environment. So by default, all of the calls within Dapr-enabled Dapr-enabled applications are traced, and they also provide metrics, right? So we provide a ton of metrics to help you understand performance, latency, error rates that are occurring within this distributed system. So there is a small configuration file that you create that essentially says you want to enable tracing, and then you can target a particular backend. So that could be Zipkin, it could be Datadog, it could be Azure Monitor, right? And there's a couple of settings that you can configure that make, that help you to work with these specific backends. But that's important to call out, right? Is this, and to keep in mind, this type of tracing, these metrics are not siloed to the Service Invocation API. So this is true of all Dapr-enabled APIs. So let's say app B in this case is calling out to a state store, we'll also get tracing information and metrics all the way to that state store at the infrastructure level, which is really critical in order to see your entire system end to end, not just the intra-app communication. And when it comes to tracing, basically Dapr will create a new trace header if one isn't provided, but you can propagate those trace headers as well. So you can provide your own that will be propagated by Dapr, or Dapr can generate a new trace ID for you at origin whenever there isn't one already. Okay, do you want to see a quick demo? Does that sound like a good time? I think it's about time. We're 20 minutes in, so we'll get into this demo. So we're gonna have two applications running locally here. We're gonna have the checkout service, the order processor, both of which have their unique Dapr app IDs. And I'm gonna show you what it looks like to see that resiliency in action, and essentially what kind of metrics and the way that we can see traces basically out of the box. So let me close all of this out here and pull up Visual Studio Code. Is there a way for me to make this go away? Nope. All right. Does anyone know how I can hide this? I should
hide what?
Let's see. Just this. You can't see the bar that's covering my screen. You can't see it. It's not there for you.
No.
Okay, no worries. Well, it's not there for you, so we'll just pretend it's not there. Okay, so we're dropped into a local VS Code instance. And I just want to call out a few things and also caveat that this will be available on the Diagrid Labs repo today. I just got permission, so I'm going to work with Mark, who's our host today, to make sure that the both this demo and the demo that Sam will be showing is available for you. Okay, so let's just take a quick look at our application code. I'll zoom in here just to make sure everyone can get a good peek. So we have two applications. We talked about that checkout, which is going to be our invoking app, and the order processor, which is going to receive that invocation. And it's super basic. This one's written in Python. So that's just a reminder, right? Dapr enables polyglot service invocation, regardless of language, even protocol, right? Protocol translation can happen via Dapr if you're invoking on HTTP and receiving on gRPC. So this is just something to highlight. So super basic app that we have, very simple code to invoke that other service. We're essentially doing a post request. We're passing in the Dapr URL, which in this case is a local host, and then the port that Dapr is running on. So in Kubernetes, it's going to default to 3500, but I can also set a local environment variable and override that when I'm running multiple sidecars. And obviously there would be port conflicts if they all ran on 3500. And then I'm also passing in the name of the method here that I want to invoke on my order processor service. So this doesn't look like that v1 invoke endpoint, and that's because there's a couple ways to use the Service Invocation API. One is you can actually pass in the app ID as a header. So you can see here, I'm passing in the order processor to an environment variable called invoke app ID. And then whenever I am making that request, I'm passing in the Dapr app ID as a header. So when I pass in that app ID as a header, I don't have to use the same v1 invoke schema. Instead, I can just basically say, where's my Dapr endpoint? What's the method name? And then it knows that it's calling the order processor app ID because of this header. So super basic, we're doing a post to that method on this app ID. And then essentially the order processor, which is a node application, is going to receive that post on the new order method, and it's going to store that in state. So you can see here, we're doing a fetch, we're passing the state URL, which is v1 state, and we're giving it a name. So we're just passing in order state as the name of a component. So to really highlight, we made a service invocation request with essentially a single line of code. And then we store to a Redis state store without any Redis logic, any Redis plumbing, any SDKs. All we have to do is basically pass in this URL and the name of the backing component we want to use. So that's the code in a nutshell. And I'll just quickly show you, I have a set of resources here that are essentially critical to some of what we just talked about. So one of them is the state store. You can see here it's called order state, and it's targeting state.redis. What's cool about Dapr is when I'm running it locally on my machine, I automatically get a Redis container running on Docker that I can use in order to test state management and PubSub. So we're just going to target that local Redis running on Docker, and we're going to scope it to that order processor app, which will store orders there. Now, we talked about that resiliency.yaml. So let's take a look at that and kind of understand what we have here. So you can see here, I have a resiliency policy or a resiliency object. And within that, I give it a name. So we'll call it checkout resiliency. And I scope it to the checkout app. So this remember, this tells the resiliency policy, hey, the checkout application will use these particular policies on these particular targets. So we've created two retry policies here. Two policies, one retry, one circuit breaker. And you can see this is a retry forever. So I'm giving it an arbitrary name called retry forever because that's exactly what we're doing. I'm saying retry forever. And basically I want this to happen constant. So there's not any kind of like exponential back off for these calls. And then the circuit breaker that I've created is called simple CB, which is simple circuit breaker. Max requests. So this only kicks in once your circuit breaker is half open. So basically what it's saying is after 5 failures, which we're going to continue retrying forever. So we'll retry 5 times. After that 5th retry, we're going to trip the circuit breaker. And then we're basically saying, I want to wait 15 seconds after the circuit breaker is open to allow 1 request in. And this could be 5 requests, 10 requests, but we're basically just saying how many requests do I want to let in after 15 seconds of a circuit breaker being open when I basically make it half open to receive and try out and see if it's recovered. So once we've established the policies, we then can target a specific application and we can tell the application can define which policies it uses. So let's say I had 3 circuit breaker policies. I can still say, hey, when I'm targeting the order processor from the checkout, we use the simple CB. When I'm retrying calls from the checkout to the order processor, I want to retry forever. So hopefully that makes sense. And we're going to see this in action. And then the last thing I wanted to show you is our configuration. So in addition to having these like resiliency policies, right, we have configuration that we can set for each of our applications, which basically say, hey, I want to enable metrics. So this is by default true. I can enable API logging. In this case, I said false. It's pretty verbose, but it gives more visibility into the API calls that are coming from the sidecar. I can also enable tracing, and I can set a sampling rate and actually pass in an endpoint address for Zipkin, which is saying I want to use Zipkin as the visualizer or the backend that I use to visualize these traces. And I'm going to do the same thing for the checkout config. So this just goes to say for observability purposes, we need that tracing. We want to enable metrics, which happens by default. And then if you want API logging, you can also add that and enable that. Okay, so let's get our apps up and running. Sorry, once again, there's like a little bar on my screen. I can't seem to bend there. Okay, so I have both of these apps running. That was more to generate demo data. So we're going to clear these out and we're going to rerun these together. So there's a couple of ways I can run both of these applications. For the sake of demo, I'm just going to run them as 2 separate commands, but I could also run a multi-app file, which runs both my Dapr sidecars and both my apps at the same time. So for the sake of this exercise, we're going to run our Dapr run command. And we can see here, we're going to run the order processor. We're going to highlight a couple things. So I pass in my resources path. This is how I tell the sidecar to load up that config, to load up the resiliency, to load up the state store. I pass in some information about ports, right? Where do I want my metrics port? What's my app port, aka where's my app running? And then where should that sidecar be listening? And then I also specifically specify the configuration file for the order processor. And then I'm running the node app using the node app.js command. So let's run our order processor first. And we'll see some fun output here. Everything looks like it's up and running. So once again, the important thing to call out is that everything is loaded. So we see metrics or server started on 9090, which is important because I'm going to show you those metrics in just a second. We can also see here we loaded our state store, which is great. We always want to check for that. And we can see that we have tracing and metrics enabled. And then we can also see that our application is up and running, and we're already starting to get some of those traces. So Now I'm going to have some fun and we're going to run our checkout application. So this is going to just immediately start posting to the order processor service. So if I do a Dapr run, app ID, checkout, we can see very similar input. I have to give it a different metrics port. I'm providing the HTTP and gRPC port. I don't have an app endpoint because this app doesn't have a publicly exposed endpoint or even an exposed endpoint at all. And then I'm passing in that checkout config. So we'll run that. You should see pretty similar output. And now we can see we're already getting those API logs, which are saying HTTP API called, and we can see it's post new order. And we can see that our app is logging these traces as well, and also persisting those orders in state, which is great. So we can see this is all running and looking good. And now I kind of want to show you what happens if, maybe the checkout service, or excuse me, maybe the order processor goes down, right? So that checkout service is consistently invoking using the service invocation API. What happens when it no longer has something to invoke? So let's take a look. It should take just a second. We should see that we're going to start getting some errors here. So you can see the first time we get this error processing operation, retrying, then we can see the state of the circuit breaker changed from closed to open. We can see that the circuit breaker is open, which is why our direct invoke is not working, and the app is actually returning that. So we can see that our application attempted to make the call and is acknowledging that the circuit breaker is open. And then we saw it went half open and it allowed one request in, which also failed because obviously the app has not recovered yet. So let's just rerun this for the sake of exercise. We should see that it immediately starts recovering. The circuit breaker will eventually close, and we'll just give it a second. Okay, so we see now that the requests are coming through, that they're succeeding, and we should hopefully see that things start persisting and that the circuit breaker closes. We can see here on the other side that it is persisting. So let's see if we're able to recover on this side. Yes, so we see it here, the half open to closed. So that's where the circuit breaker closed, and now the requests are going through as expected. All right, awesome. Okay, so the last thing I want to show you here is the metrics. So as I mentioned, and let me just flip over. As I mentioned, we get tracing and metrics because of that config. So this is an example of a Grafana dashboard. We have the ability to enable Prometheus metrics for the Dapr sidecar. So you saw that I set a metrics port of 9090 and 9091. And then in my Prometheus config, I basically just said, hey, I want you to scrape localhost 9090 and localhost 9091. And then I imported that Prometheus data source into the pre-built Grafana dashboards that Dapr open source has as part of the release artifacts. So you can see here the various calls that are happening over time. If I look over the last 30 minutes, we can see a lot of progress there, a lot of motion. I can select one or more app IDs. I can see the request rate, which is around 1, which makes sense. We're posting about once every second. So this just kind of goes to show you, right? I'm getting metrics. I'm getting the ability to scrape these Prometheus endpoints. And then also I got Zipkin out of the box. So let's go ahead and update this to, we'll just go ahead and make it a time in the future. But we can see here, we get a dependency graph just by enabling that tracing where the checkout service is invoking the order processor is storing things in state. I can click in and I can actually see the number of calls and errors. I can see the traces based on the application ID. And this is actually filtered, but I could literally see, traces from the last 15 minutes and go through and kind of see performance, latency, any errors at the start time. So we see those are consistently coming in. So all of that pretty much out of the box, which is awesome. So just kind of wanted to give you a highlight of those things. We are at 9:40, so I want to be conscientious of time here. I'm just going to switch back to that presentation to make sure that Sam has enough time to proceed. I was going to show you another cool demo running on Kubernetes with MTLS. Unfortunately, we don't have the time because this ran a little bit longer than I expected. So let me just
time flies when you're having fun, right, Kendall?
Exactly. Yes, exactly. There's just too much goodness in this API. And I apologize, I lost my slides. So let me pull these back up. Here we go. We love a good switcheroo here. Okay. Can y'all see? Can you see okay? Are we back in action?
Yes.
Yes.
Okay, perfect. So I was going to talk and show how MTLS works within a Kubernetes cluster and show you how access control lists work. Unfortunately, I want to make sure Sam has time for her awesome workflow and external endpoint demo. So I'll leave these slides for all of you to take a look at. But the main highlight here is that through our application IDs combined with SPIFFE identities and the Dapr control plane sentry service, we essentially get that MTLS encryption. And then we can also set access control policies, which basically say, hey, app A is not allowed to invoke app B at this endpoint, or is only allowed to perform this operation. So we can establish trust domains, we can establish specific operations that applications can invoke or call on another application. And then we also have Dapr middleware, which is essentially something you can use on your service invocation calls. So we have API middleware, which is from your application inbound to the Dapr sidecar, and then from the Dapr sidecar to the application, we have app middleware, which can be applied as well, and it can take that same route back. There's a great recent demo that was done on a Dapr and WebAssembly using, Dapr middleware plus WebAssembly, which is really cool. So I recommend checking that out as a follow-up. And then we were going to show a cool benchmarks, once again, we'll share, but really adds very little latency, 1 millisecond latency in the 90th percentile for service invocation calls, which is very standard for, traditional service meshes, so very comparable. So I'll leave this demo in the repo for you to play around with. And what I really want to do is hand it over to Sam. So Sam, do you want to go ahead and share your screen, and I'll let you take it from here.
Thank you. All right. You might see yourself for a second. Here, I'll just minimize it. There we go. And then share my screen. And hope I share the right one, right? Okay. So hopefully everyone can see. And let me, oh wow, now I see what you mean by the bar, Kendall. Let me get this correctly precise. Oh, I'm sharing the wrong one. Okay. Let me share this one. Okay, and then get this. I'll get my handy dandy notes for everyone. Okay, wow. This is a lot of steps to get this enter full screen. Okay. So hopefully everyone can see my screen, and okay, cool. So when it comes to using service invocation in your applications, Kendall did a fabulous deep dive for all of us, and I wish we had more time to go over all of the other amazing things you get with it. So with service invocation, right, you can invoke HTTP and gRPC services using our service invocation API. You can make direct callouts to the API, or you can use an abstraction layer through the Dapr SDKs, again, in all of those different languages. So you have a lot of flexibility. And so there was an ask here recently in terms of, what if I'm in some sort of a scenario where I want to call a non-Dapr HTTP endpoint. So for this, there's other use cases where you might want to communicate with other services that are just external to your overall application. Maybe Dapr is only used in part of your architecture. So maybe you're in a brownfield development scenario, or there might be a case where you cannot migrate your code to using Dapr. So you need to call some sort of an external HTTP service. And for that, we have the new feature in v1.11 for invoking non-Dapr endpoints. So it's new. And yeah, so that was a really big ask of the community. So we'll be covering that here. In terms of service benefits that you get with the service invocation API now for all endpoints, right? Kendall covered a lot of these different API benefits like service discovery, standard API calls. Consistency is key. especially when it came to thinking about invoking external services. We wanted to keep the same look and feel, and basically do a service invocation API ++ for everyone. So that way you still got the resiliency and observability and security and middleware out of the gates, but for external calls. So if we think about it from the perspective of those diagrams that Kendall was sharing, you know, we have our app A, and we have our app B, where app B is a non-Dapr application, so some sort of an external service. And if service A wants to call out to app B, well, service A would make that HTTP call targeting service B, which is that non-Dapr endpoint, and it goes through the Dapr sidecar of app A. And Dapr discovers service B using something called an HTTP endpoint. So this is a new resource as of v1.11, where you can specify this Dapr resource with things like a base URL, header information, and so forth. So that way the Dapr sidecar knows where to send that request. Then Dapr forwards the message to service B. Service B can do its business logic, and then service B can send the response back to the sidecar and then thereby back to service A. So that's kind of the flow. Again, very much the same, just a few differences. So we talked about, we have a new resource, and you can see there that I have the kind HTTP endpoint. I have named it my endpoint, and I have a few different specifications in terms of the base URL, the headers. And so, you know, whenever you're thinking about invoking other services, you might consider authorization headers. And in our example here in a bit, I will show you what that looks like with just a string, but you can use a secret key ref to keep it much more secure. And again, you see scoping where I can scope this resource to app A. In terms of consuming this resource, then we have our SDK approach where you can create that Dapr client, where you can, it's a create invoke HTTP client. And as Kendall mentioned, app IDs are crucial in Dapr. And so here you can see my app ID in this case is my HTTP endpoint name, my endpoint. And then I can invoke using a post request to my method that I want to invoke. And you can see the API call there as well, where it's the consistent approach we've been seeing in these slides, where it is the invoke API, and you can see I'm invoking my endpoint. So here you can also specify a URL directly. However, the preferred approach is to go with this declarative model, so that way you can use kubectl to edit and modify this as you need if you are working in a Kubernetes environment. And now I'll kind of go over Dapr workflows quickly, so that way I have a few minutes for the demo and then a few minutes for QA. So bear with me, because we are at 11 minutes. So I'm going to be mindful of everyone's time. When it comes to Dapr workflows, they came out in Dapr 1.10, and they've had some awesome updates in 1.11. And there are a few different components to Dapr workflows. And activities are the basic unit of work that you can think about in a workflow that orchestrates and is executed as a part of your workflow. These activities perform business tasks that are defined in a specific order that you want within your workflow. Dapr workflows allow you to implement things like durable timers, where you can set delays in a workflow. And you can even have child workflows in the case that you might be working with a much more complicated scenario. And these child workflows allow you to optimize for performance and scalability, as well as the workflow state management, because it is going through event sourcing here. So we're saving what's happening as the workflow goes on. As of Dapr 1.11, workflows can also wait for external events mid-execution. So maybe in the case that we need to wait for user input for something, then we can now wait thanks to the latest release. That was kind of Dapr workflow concepts at a high level, and now we'll think about it from the perspective of that Dapr sidecar, which contains the Dapr workflow engine. So it's this Dapr sidecar that is managing our state and is what is executing, orchestrating, and managing all of our workflow activities. that we have specified in our application logic. And that's pretty much like the big thing here is Dapr manages all of this for us. In terms of the Dapr workflow SDKs, right now .NET is the one that was supported for 1.10, and Python was another addition in v1.11. So again, more and more support as we progress. In terms of Dapr workflows runtime behavior, I'll go ahead and share a picture. And so it's that same one we basically saw on the last slide, where we have a user-defined workflow in our application that we've used the Dapr workflow authoring SDK, and we have our associated Dapr workflow engine running in our Dapr sidecar. So we've started our service in our Dapr sidecar, and at this point, our authoring SDK from our application will initiate a gRPC stream to the Dapr sidecar, which will be used to receive commands from the Dapr workflow engine and return results. Now, using the Dapr workflow management API, you can initiate workflow actions such as, hey, start my workflow, or pause it, I need a sec. Or you can also get the status. And based on requested actions, the workflow can send a series of work items to your application, and then the application will return the results back, which will be stored in a state store. So I have a demo application and I have a few minutes to cover it, but basically what we have here is we have a workflow called checkout workflow. And this is taking a user order and attempting to process payment. So you can see there, I have 5 different activities. And the one that we'll really focus on is process payment activity. So this process payment activity within our checkout workflow will invoke the external non-Dapr-enabled Square API using an HTTP endpoint resource to process the user's payment. And that way, right, Dapr knows where to send that request. So now we'll go ahead and have one more slide on what you can see for the HTTP endpoint. So you can see here, I've named it Stripe Payment. I've specified my Stripe Payment API, base URL, and a few different headers. And you will see my plain text bearer token. So don't copy it, but it's just for demo purposes, so it's fine. And then also we have the create invoke HTTP client that we're using. And again, it's that HTTP endpoint resource name for the app ID. And then we're calling out to method v2 payment with the data for our post request. So now I will share with y'all the demo. So let me go ahead and pull this over here. Okay, so hopefully y'all can see my VS Code, and I don't want to go back and forth switching screens, so I'm just going to leave it over here for a second. I'll zoom it in. So basically, and let me move all of this over because I will want this later. Okay. Basically, you can see here, VS Code, it's our example demo for workflows and invoking an external service. We have our checkout service here, where we have our workflow activities, as well as the workflows directory here. And then we have our Dapr resources, where we've defined our HTTP endpoint. So let me see over here. Okay. I will go ahead and start with the CS proj file. What this looks like is you can just see we're working with .NET here. And for our example, we are using the Dapr SDK. So you can see we're working with a Dapr client and the workflow. But again, you don't have to go with it this approach. Next, I will show the program CS file. For this, I'll keep it high level to keep in mind time, because I probably want to give like 2 minutes for QA. But we added Dapr workflow. You can see we are registering a workflow here. It's called checkout workflow. And we're registering a few different activities. And the one that we will kind of hone in on is that process payment activity. And so now we will look at our workflow. So you can see here, I do have a checkout workflow. And basically the important thing here is we're taking in one thing and we're spitting out another thing, right? So I'm taking in a customer order into my workflow, and I'm responding and sending out that checkout result. So that way I know what happened in my workflow. I have a few different activities going on here, and you can see that with the call activity async. So here's our notify activity. Here's a checkout, check inventory activity. And then here is the call async activity for the one that we'll be talking about, which is the processing payment to call out to that external service. So we're going to process our payment. We have our process payment activity, and we're saying, hey, this is my payment request. And you can see I have a few different things here for my payment request to send out to that API externally. And then what that looks like from the process payment activity perspective, right? We're going to be making an external call. So we have our process payment activity. And then if I scroll down, you can see I'm working with the Dapr client on line 21, where I'm saying, hey, use my external HTTP endpoint for this external call to process payment. And then I have my create payment data that I'm specifying here that I use in my post request with my Dapr client. So this, in just a few lines, we've shown how you can call out to an external service. So now let's see what that looks like running. And it's a similar command that you saw with what Kendall was running. We use Dapr run, have a few different flags going on here. We tell it the resources to load up, and then we're saying, hey, run my application. And so now we know that we've started the Dapr runtime. We have loaded in my Stripe payment HTTP endpoint. And that is pretty much all I want to show y'all on this. And then I will show you this. And I'm going to speed it up because I want a minute for everyone. So I will start my workflow.
Also, Sam, we've been answering a lot of questions. So I would just encourage, if you have questions, drop them in the chat so that you can, yeah, no worries, you're good.
Thank you. Okay. I think, okay, I lost my terminal there. But yeah, okay, we started our workflow and it probably was too slow, but we can see, yeah, actually I was slow. The workflow is completed, so I'll go ahead and redo this so we can kind of see it. Oh, send request. So we can see my workflow is running. It's checking if I have inventory for this request for our checkout workflow. You can see now we're in the next activity, right? It's following the order I've specified. We're in our payment processing activity. My workflow is still running. And let's see if it was successful. Checkout has completed. So the payment went through. And we also had it randomized. So I didn't know if it would work or not in terms of being a successful checkout. But let me show y'all real quick what that looks like over here. So basically you can see that, you know, we did have a call out and it was a successful request to this Square external API. And as Kendall mentioned, you know, we get Zipkin out of the gates. So we get a lot of really nice tracing information here. And that pretty much covers the demo because I know I'm almost out of time. So I will quick speed through some of the awesome release highlights.
I think it's good, Sam. We're right at time.
Oh, okay.
Just to be conscientious of time, we'll probably end here.
Okay.
We have some more slides. We're gonna throw the slides in the repo, or we'll send out the slides after the session. You'll be able to go through all of these. We covered some release highlights, some service invocation updates, and then Sam showing the slide that basically is just how you should get involved. So we have some recent community calls on auth with Dapr, non-Dapr endpoints. We have Discord, YouTube. We have, like mentioned, every 2 weeks, we have a call that you're welcome to join as part of the community. So we'd love to see you there. And then obviously, like if you're running Dapr at scale and you're interested in taking Dapr to the next level, reach out to us. We'd love to talk to you about Diagrid Conductor and some of our other capabilities at Diagrid.